We are sticking with section 8.1.
See.
We're sticking with 8.1, but we are going to move on to recursive formulas and factorials.
Sounds hard.
Sounds hard because they're fancy names. Last year, if you had me, we talked about this thing called the Fibonacci sequence.
Oh yeah.
Do you remember that?
Yes.
I gotta make sure I spell this right.
ICCI.
ACCI.
Oh, yeah.
And
that's what
we're
I
not
said.
going to talk about it much this year, but it's a really good sequence to talk about when you're talking about recursive formulas. So the Fibonacci sequence, I'm going to list the Fibonacci sequence for you in just a second. But the Fibonacci sequence is recursive because it requires you to take previous terms to get to the next term. So it is recursive. Because you need previous terms to get to the next term. That's what recursive means. Recursive means you have to rely on the previous term to get to the next term. You can't figure out the next term until you have the one right before it. Is that what you were going to say?
Yeah, I was
Yeah.
going to say that.
So that's what recursive means. Recursive means that you have to have previous terms to get to the next one. The Fibonacci sequence is this. Fibonacci sequence starts off with 1, and it takes the previous term to get to the next term. So I'm going to start off by saying the recursive formula is 1, comma 1. How do you get to the next term? You have to add together the two terms that you already have. 1 and 1 get you 2. Now to get to the next term, you have to add together 1 and 2, which gets you 3. To get the next term, you add together 2 and 3, which gets you 5. 3 and 5 gets you 8. 5 and 8 gets you 13. 8 and 13 gets you 21. 13 and 21 gets you 34, etc. That's the Fibonacci sequence. Perfect example of what we call a recursive formula. Can I flip? May I? Sorry, Alec. Teachers are supposed to say that, not you. All right, so in this case, the very first number right here is referred to as being the 0 term. This one right here is called the first term. This one right here is the second term, and so on. I'm not going to list them all, but a sub 0 is equal to 1. A sub 1 is equal to 1. A sub 2 is equal to taking a sub 0 and adding to it a sub 1, which of course gets you 2. The third term, what do we do specifically in terms of term numbers to get to the third term? What do we add together? A what?
1 and 2.
A1 and A2, A sub 1 and A sub 2, which got us, what did it get us? 3. And then the fourth term would be equal to the what term and what term?
2 and 3.
The second term and the third term, etc. You guys with me here? So let's say that we kept going and we had to find the kth term. The kth term, not the 5th term, not the 10th term, and so on. What would you do? What would be, how would we write that? We don't know what k is.
That's 11.
So we have to write it in terms of k.
That's 11, right?
That would be 11? Oh, did you go A, B,
Yeah.
C, D, E, F? No. That's very cute though.
Um,
The kth term.
And that would be 1/4.
Yeah, this isn't Mexico, Richard. All right, just when we're writing a rule to find any term number. So if we wanted the fourth term, we had to take two terms right before it plus the term right before it. Would you agree with that? The fourth term was two terms before plus the one right before. So to find the kth term, we need to take the term that is 2 before k. What's 2 before k? And I'm not talking about the alphabet right now.
K minus 2.
Say it again.
K minus 2.
K minus 2. K minus 2. It's two terms before, so it's k minus 2. Does that make sense?
Yeah.
A sub k minus 2. Plus you have to add to it the term right before it, which is a sub
K
k
minus
minus
1.
1.
She got so excited. He's
I
Mexican,
was
got it
so
right.
happy.
Hey, he's Mexican.
That is not what I was thinking at all. I didn't think that about Richard, not about anybody
She was.
else. All right. So let's get to some examples.
Okay.
All right, so examples, let's say the first term, a sub 1, is equal to 10, and a sub k plus 1 is equal to a sub k plus 5, and you need to find the first 5 terms. Find the first 5 terms. So, the notation,
Wait, is
I
that-
think, for these things, what's the matter?
Is that a sub 1 equals 10?
A sub 1 equals 10, yeah. In other words, the first term of this sequence is 10. Now, this is actually not difficult, but I think the notation is kind of strange. So this is our recursive formula. This thing right here is our recursive formula. And it's telling us that to find a term, a sub k plus 1, that's just, that is the name of any term in the sequence, you have to take this term right here. Well, what is a sub k in comparison to a sub k plus 1?
It's 1 less than.
Yeah, it's the one right
Before.
before the one you are trying to find. That's the difference between k and k plus 1. K plus 1 is the one you're trying to find. But to find that one, you need to take the term right before it, which is just a sub k, and then you have to add 5 onto it. So if you have to find the first 5 terms, and I tell you that the first term is not 5, the first term is 10, what is the next term? It's going to be 15. So to find this term right here, you had to take the one right before it to get to that one. Now to find this one right here, you have to take the term right before it. Well, what is 15 plus 5? 20. So now to get to the next number,
25.
you have to take the one before, which is 20, and add 5 to it. So you get 25. So 10, 15, 20, 25. I think you got the hint. You got the pattern. Once you get the pattern going, it's not a big deal.
So we wouldn't add the 2.
Not the 2 previous. The example that I gave you was the Fibonacci sequence, and the rule for that is that you add together the first 2. This rule is that you just take the one before it and add 5 to it. What'd you say?
It's not Fibonacci.
This is not the Fibonacci sequence, no.
How would we be able to tell when to use Fibonacci?
Fibonacci was one example of one sequence. Every sequence that you're getting is going to be different. I was just showing you that the Fibonacci sequence is recursive. But that recursive formula requires you to add together the previous 2 terms. This is a completely different sequence, and it's asking you to take a term and add 5 to get to the next one. And then you take that term and you add 5 to it to get to the next one, and so on. Completely different sequence, but the same kind of thing. It's requiring you, like you couldn't figure out this term until you had the one right before it. That's why it's called recursive. Just like in the Fibonacci sequence, you couldn't figure out a term unless you had two terms before it. You couldn't figure out the 50th term unless you had the 48th and the 49th. Were you going to say something?
I'll tell you later. No,
Alright, what about this? The first term is 27, and the rule is a sub k is equal to negative 4. I'm sorry, it's k plus 1 is equal to negative 4 times a sub k.
A sub
Alright, so to do this,
Oh man, that looks hard.
what is the very first term?
27.
27. So according to our rule, our recursive rule right here, to figure out any term a sub k plus 1, you have to take the term right before it, a sub k is the term right before it,
Subtract
and
4.
what do you have to do to it?
Subtract 4.
No, not subtracted, it said, and I know some of you said it right, it says negative 4 times a sub k. So you have to take negative 4 and you have to multiply it by the number that you already have. So in this case, you're going to take 27 and you're going to multiply it by negative 4. What is 27 times negative 4?
109.
Negative 108.
That's what I meant.
Notice you are multiplying by a negative. If you are multiplying by a negative, what's happening to the numbers in your sequence?
Others flip-flopping.
Yeah, every other number is going to be negative. So if we start with the positive and then go to our negative, the next number is going to be a positive. Okay, so help me out here. What's negative 108 times negative 4?
432.
432. Now you take 432 and you multiply that number by negative 4. I don't know what you get.
1708, I think.
negative 1728.
28, yeah.
Negative 1728. All right, so we go positive, negative, positive, negative. The next number is going to be positive. So negative 1,728 times negative 4 is going to get you
Negative 3,000.
6,000,
912.
and it's positive.
Yeah.
The big numbers.
All right.
I said
More. Bless you.
Thank you.
Welcome.
Factorials. Factorial, if n is a positive integer, then n factorial is defined as, first of all, you write it like this, n with an exclamation mark. Has anybody ever seen this notation before?
No.
N with an exclamation mark, and it means this. N factorial, this is the symbol for factorial, that exclamation mark. That is equal to 1 times 2 times 3 times 4 times 5 times 6
And
times
so on.
7. When am I going to stop?
Ever.
Where? When?
Never.
You do stop. Stop at n.
Don't
If
buzz my
it's
motion.
n factorial, you're going to stop at n. So I could keep going. I don't know what n is. N might be a million.
It's
N might
28.
be 4.
20.
N might be 6. It might be 12. It might be 137. I don't know what it is. So I stop at n, but what number comes right before n?
N minus 1.
N minus 1. Very nice. So I'm going to keep going until I get to n minus 1. And then n minus 1 has to be multiplied by the very last number, which is n. That's what factorial means. So an example of that is, what if I asked you to do 5 factorial? What does 5 factorial mean? 1 times what?
2.
2
Times 3.
Times 3.
4 times 5.
times 4 times 5. You're done.
That's it. You don't have to equal it out.
Well,
Oh.
depends on the problem, but sure, let's do it. What's 1 times 2
120.
times 3? I think it is 120, yeah. You get 120. Now, there is a little shortcut for that, you guys, on your calculator. If you type 5,
Does that have to do with colon P?
yeah, go type 5, and then arrow all the way, no, press math, and then arrow all the way to the right to probability.
Yeah.
You see it?
Oh, I see it.
Arrow all the way to the right to probability, and I think it's option 4. Maybe not on all of the calculators, but you see an exclamation mark.
Yeah.
Press, select that, press enter, you should
Enter
get 120.
Over.
So 5, press 5, and then math, over to probability, select the exclamation mark, press enter, you should get 120. I think if you type in numbers that are really, really big, the calculator doesn't have the
Says
power.
overflow.
Yeah, the calculator doesn't have the power to calculate all of them for you. I mean, if you think about it, if you're going up to 1,000, that's 1 times 2 times 3 times 4 times 5 times 6 times 7, all the way up to 1,000. I mean, that's a really big number. All right. Do I need to do a bunch more examples of this,
No.
or are you?
We're good.
We're good.
All right. I do want to give you this though. What about 3 times n? 3 times n factorial. What about that? What does that mean? 3 times n factorial.
3 times 1, 3 times 2 is that
Well, it actually means the only thing that's getting the exclamation mark is the n. So it's actually 3 times, and then in parentheses it's just n factorial. So it's 3 parentheses 1 times 2 times 3 times 4 times 5, etc. Where do I stop?
N.
You're gonna stop at n. What comes right before n?
N minus 1.
N minus 1. So n minus 1 times n. Finish your parenthesis, because whatever answer you get for that, what has to happen to it?
It's got to be multiplied by 3.
It's got to be multiplied by 3. Yep. This one you couldn't type into your calculator unless you knew what n was. But yeah, that's what you would write. Yep. What about this? What if the 3 and the n were in parentheses to the factorial? How do they always start?
1.
They always start with 1, and they go to 2, and they go to 3, and they go to 4, and they go to 5, and they keep going. What's the very last number going to be?
N.
Not n.
Minus 1.
It's going to be this whole thing, which is,
Minus.
okay, so 3n is our last number. What would be right before 3n? 3n minus 1. So you do 3n minus 1, and then the very last number is going to be 3n. And you're done. By the way, definition of 0 factorial, just put a little star by that. 0 factorial is defined as being 1. 0 factorial is 1. Can I flip pages? Alright, an example, let's do a sub n. This is, I'm giving you a rule. It's not recursive, it's just a rule. A sub n is equal to 2 to the n power over n factorial. And I would like you to find the first 5 terms. Find the first 5 terms. So that means you need to find term 1, term 2, term 3, term 4, and term 5. So what is the first term? First term is going to be 2 to the power of 1 over 1 factorial. So what is 2 to the power of 1? It is 2 divided by 1 factorial. Well, 1 factorial is 1. What is 2 over 1?
2.
Is 2. The second term, a sub 2, would be equal to 2 to the second power divided by 2 factorial. factorial. What is 2 squared?
4.
4. What is 2 factorial? What does that mean? 1 times 2.
Is this gonna be a pattern?
So we have 4 over 1 times 2 is 2. What is 4 divided by 2?
2.
It's equal to 2. Is the next term going to be 2?
Could be.
No.
Let's find out.
Probably.
The third term, 2 to the power of 3 divided by 3 factorial. What is 2 to the power of 3? 8. Okay. 3 factorial means 1 times 2 times 3. So we have 8 over, what's 1 times 2 times 3? 6. What is 8 over 6?
4 over
4 over 3. So it was not 2. The fourth term, a sub 4, I might do some mental math here. 2 to the 4th power is 16. 4 factorial. Well, you guys, you know what? 4 factorial is 3 factorial times 4. 3 factorial I figured out previously is 6. What do I multiply the 6 by to get to 4 factorial? You just multiply it by 4. What's 6 times 4? 24. What is 16 over 24?
2/3.
2/3. Good. Alright, and then the fifth term. Well, the fifth term is going to be 2 to the power of 5, which I believe is 32. In other words, I'm taking the previous numerator and I'm just multiplying that by 2 because I'm only putting it to 2 to 1 more power. So I have 32 over, and then the denominator is going to be 24. But what do I have to multiply it by? 5. 24 times 5, which I think is 120. Now, for those of you that don't know what I'm doing, you can go through and do every single one of these terms the same way that I did, the previous terms. You get 120. What does this reduce to?
14, 15.
14.
4,
15.
Yeah. What did you do for the last one? Multiplied 24 times 3?
Yep, I multiplied it by 5. Because I'm doing, on the bottom I would have 5 factorial.
Right.
Well, this 24 came from doing 4 factorial.
4.
5 factorial is just 4 factorial times 5.
Oh, okay.
Times one more number, so that's where the 120 came from. Okay, so we have 4 over 15. All right, one more example, and then we're going to be done.
Yay.
What is 10? Your assignment today is going to have you just practicing using factorials. What is 10 factorial over 7 factorial times 3 factorial?
What?
I'm gonna write this whole thing out. What is 10 factorial?
1 times 2
Where do I stop?
10.
7, 8, 9, 10. Divided by 7 factorial is 1 times 2 times 3 times 4 times 5 times 6 times 7. But then that has to be multiplied by 3 factorial, which is 1 times 2 times 3. So I'm going to go times 1 times 2 times 3. Can you cancel anything out? Is there anything in the numerator and the denominator that are the same?
Yeah.
1 through 7. All of these things in the top cancel out with all of these things in the bottom, leaving you only with 8 times 9 times 10 divided by 1 times 2 times 3. What is 8 times 9 times 10?
720.
720. And then 1 times 2 times 3 is 6. 720 divided by 6, I believe, is 120.
What? That easy?
Hold on, one more. I told you there was one more example I lied.
Yeah, you did. I give up.
What about this? N factorial over n minus 1. Excuse me, factorial. So, what is n factorial? What does that mean?
What number?
It's a
1
number that
times.
stops at,
N minus 1.
It doesn't stop at n minus 1, it
stops
stops at
after.
n. Talking about the
After that.
numerator. Right, numerator stops at n. 1 times 2 times 3 times dot dot dot. The very last number is n, so what's the number right before it? N minus 1. We have n minus 1 times n, all divided by, and then the denominator, how far do we go? Where do we end in the denominator? We divide it, we stop at n minus 1. So we're going to have 1 times 2 times 3 times all the way out to n minus 1. And that's it, I stop right there. What cancels out?
Everything.
Everything except for
N.
n. This is all gone. That's all gone. All you are left with is n.